Welcome again. In this video, we're going to talk about data frames in Python, which are a more complex data structure that can help us describe data and perform statistical analysis on it. So, data frames are just tables, similar to when you build an Excel table to compute your marks in a subject or to compare shop any item. It has rows and columns. The first row may contain a header, so it shows you the label with the data. And it's a very useful tool and very efficient tool compared, for example, to lists and Python dictionaries to work with large amounts of data and analyze it. Data frames are not included in Python by default, so to work with them, we need to install and then import the Pandas library. First, we need to run pip install pandas in a terminal, for example, in VS Code. And if everything works correctly, at the end you'll see a message like successfully installed and a set of package names. Among them you'll find pandas. Then we can import pandas into any Python session or any module with import pandas. And in our case, we're going to work with pandas with the name PD for short. So we import pandas as PD. To work with it, we can start from either a data file or a dictionary. A data file is the easiest one because you can just write a comma-separated file in a file called CSV with any text editor, maybe with VS Code or even Notepad, and you can export Excel tables to the CSV format. Then you can just read it using the read CSV method, and now you have a data frame. We called it df here. You can also create a data frame from a dictionary, which is a set where the values would be product and price, and each of these has an associated list of elements. So these would be the columns, the products and the prices, and each of the elements in the lists inside, so the shirt and the pants and their respective prices, would be the rows in the data frame. Then you can use the data frame constructor in pd.dataframe and pass it a dictionary to create a data frame. You can see that data frames are very similar to Excel sheets, but there's a couple differences. The first one is that the names are included as the header of the columns instead of being their own row. This is useful because we mostly don't want to mix, for example, the word price in between the numbers that represent the prices or the name product in between the product names, for example, the shirt and the pants. We can perform many operations on the data frame, but the most important one is accessing our data. So we can use the name of the column to obtain the list of values in that column. For example, we can access the product column and save it to a variable and then print that the variable, and we can see that there are two elements. The first one at index 0 is the shirt, and the second one at index 1 is the pants. You can also access a specific location in the data frame using the LOC method for location, signaling the row and column you want to access. For example, if we want to know the price of product 0, we can find out that it's $25.99, that it corresponds to the shirt. We can also ask for the types that are stored in each of the columns. This is another difference with working with Excel, because pandas and data frames allows us to filter products and elements such that they belong to only one type. So, for example, the price is represented as a number. That's what float64 means, and products are objects. In this case, specifically strings. We can also show the first n rows of a data frame with the head method, passing the number of rows we want to see. So, for example, if we have a very large data frame and we want to see what shape it has or what possible values are contained in its different rows, we can call, for example, df.head and a value of maybe 5, 10 or 20 to see just a few values and not the full data frame. We can add new columns, of course, by using the assignment operation. On the left-hand side, we'll place the new column to be added, in this case, the data frame and the name of the column in square brackets. And on the right-hand side, we'll have a list of the values that will be added in that column. Of course, this list should be as large as the data frame has rows, And now we can print the data frame again and see that our new data frame, our existing data frame, has now an additional column. If you want, you can, for example, create a new column by applying a function to a column. For example, you want to multiply the price by 0.1 to compute the tax, for example, and store it in a new column. Or you can use a comparison to filter elements. So for example, down here we can see which are the elements that have a price greater than 30, right? So first we create a comparison, df, and the column price in brackets, in square brackets, is greater than 30. And this creates a list of true and false elements, so booleans, that we can pass as the selector to the data frame. Then it prints the appropriate rows that match the condition, and we can see which products are selected. We can also use the describe function to show a set of statistical analyses on the numerical columns. In this case, we can see the number of elements in each column, so the rows of the table in count. We can see the mean or the average and the standard deviation. And then we can see the minimum and maximum value and the quartiles of the data. So the halfway point or the median would be the 50%. And then we have the first and third quartiles in the 25 and 75% row. So for example, only 25% of products are below 29.49 euros in price. We can also specify a specific column and a specific operation if we want to just compute a single value instead of a full range and table of values. So for example, we can specifically compute the mean of the tax column and the standard deviation of the tax column, and any of the other operations we've shown in the previous slide with the describe operation. If you want, you can remove data from a data frame. In this case, you need to select the column or the row that is going to be deleted, and then select the axis. So you'll place a 1 to remove columns and a 0 to remove rows. This is because the column and the rows can be named with similar elements. So for example, if the product column was named with a 0, we wouldn't know if we said drop 0, we wouldn't know if we were to be dropping the row or the column. And finally, in place determines whether we are modifying the data frame itself or creating a new one with the deleted elements. In this case, for example, if we want to remove the units sold column, we give the name as the first parameter. Then on axis, we say 1 because we want to remove a column. And then if we select in place equals to true, we will find that the data frame itself has been modified and now it has 3 columns again. Of course, you can always remove a specific row with axis equals 0 and, for example, giving the row number, in this case, 0. Then the new rows are not renumbered, so we can see that there's a gap in the data. In this case, df has not been modified because in place was equal to false, and a new data frame has been created and has been assigned to the variable new_df. And if we print that, we can see that the 0th row has been removed from the data frame. And this is all. I'll see you on the next video.